5 reasons to forget Mars for now and return to the Moon. The distance between Earth and the Moon is 384,400 kilometers. The distance between Earth and Mars is 54.6 million kilometers. The hopes of colonizing Mars rest on the premise that we could terraform the red planet and thus make it habitable for humans and even have a breathable atmosphere and very nice temperate temperatures. But a recent study cast doubt on the idea, concluding that terraforming Mars is impossible with the present technology at man's disposal today. With colonizing Mars on hold, it's a good time to reevaluate the relationship we have with our nearest cosmic neighbor, that is, Earth's moon. The first successful lander on the moon was the Russian spacecraft Luna 9, that was in 1966. The mission revealed the barren lunar landscape in fine detail for the first time. Since the dawn of the space age, there have been over 60 successful missions to the moon, including 8 that were manned, and the most famous of those being Apollo 11 on July 1969, which resulted in the first human presence on the moon, the first day that man stepped on the moon. These space pioneers broadened our understanding of Earth and the universe, and the Apollo 15 mission of 1971, for example, recovered the so-called Genesis rock, one of the oldest rock samples ever found from a crater on the moon. Analysis of other surface samples supported the giant impact hypothesis, a now predominant view that the moon was formed from a giant impact on the Earth about 4.5 billion years ago. In other words, the moon was part of the Earth, something impacted the Earth, and the moon flew off. So the space pioneers broadened our understanding of the universe. The Apollo 15 mission of 1971 recovered the Genesis rock, as the giant impact on Earth caused it 4.5 billion years ago. And since then, our gaze has shifted away from the moon and onto Mars. In the 1990s, after a string of failures, Mars Pathfinder delivered the first rover onto the surface of Mars. It was the first successful landing on Mars since the Viking probes of the late 1970s. The pictures that the probe returned set the public's imagination aflame, stoking interest in new missions to the red planet. Rather than mourning the immediate prospect of a manned Martian mission today, we present 5 reasons why the moon deserves another look and more than just a flying visit. Why is it, a lot of people ask, that man has never gone back to the moon? What stopped man from going back to the moon if everything was so successful getting there? Now, 5 reasons why the moon deserves another look. Number 1, a staging post in space. To overcome the pull of gravity and reach another body in space, you need to achieve a certain speed. A journey to Mars from Earth's surface requires a minimum total speed of nearly 30,000 miles per hour. That's approximately 13.1 kilometers per second. This requires large rockets, tons of fuel, and complex orbital maneuvering. Due to the moon's weaker gravitational field, the same journey from the lunar surface would only require a speed of about 6,500 miles per hour, or 2.9 kilometers per second. So 6.5 from the moon is compared to 30,000 from Earth. So it's roughly a third of that necessary to reach the International Space Station from Earth. The moon also possesses a wealth of mineral resources, including valuable metals and the ingredients for rocket fuel, which is produced by breaking down water ice into hydrogen fuel and oxidizer. The mineral troilite, an iron-sulfur compound very rare on Earth, is also present on the lunar crust. The sulfur from troilite can be extracted and combined with lunar soil to produce a building material stronger than Portland cement. meaning a settlement could be constructed on the moon using locally sourced material. Establishing a lunar base from which to launch deep space missions would massively increase the payload to fuel ratio, allowing us to explore the solar system at a fraction of the current cost and effort. And the second reason is fueling the future. Nuclear fusion, the process that fuels stars, could provide our future energy supply. Fusion reactors in the future will use the helium-3, a lighter version of the helium used in party balloons. This isotope is rare on Earth, but it's abundant on the moon, where it could be mined, something which has already attracted interest from a number of businesses and governments willing to ship it to Earth. This initial burst of commercial interest could provide the incentive and finance needed for our first forays into establishing a permanent human presence on the moon. Number 3, Rock of Ages. The moon is an inactive world. No major geological changes have occurred in the last 3 billion years. On Earth, surface features are weathered by rain, tides, wind, or plant growth. The lunar landscape proudly displays a record of its violent past in the form of impact features, offering a preserved history of the solar system which is ready for us to explore. Number 4, observing the universe. The atmospheric density of the moon is thin, a 10 trillionth of that on Earth. This absence provides the perfect conditions for astronomical observations across the full breadth of the electromagnetic spectrum. A radio observatory on the far side of the moon would be completely shielded from the radio chatter of Earth. A low-density atmosphere also makes a ground-based X-ray or gamma-ray telescope possible, unlike on Earth where short-wavelength light from space is blocked. Such observatories could be maintained and upgraded by a human presence on the moon far more easily than an orbiting telescope. Number 5, humans in space. One of the major hurdles for a Mars mission is understanding how human health is affected by a long-term voyage into space. Anything unexpected occurs, resupply or rescue is over 2 years away. By testing human tolerances on the moon first and developing technology and experience, further exploration of Mars or beyond will be far more practical. If an emergency occurs on a lunar base, Earth is only 3 days away. Another major concern about going to Mars is the inadvertent contamination of the pristine Martian environment by earthly organisms. The moon is almost certainly sterile, so such concerns are moot. While the first scientific research conducted on the moon was performed in the late 1960s, in the subsequent half-century, we've come no closer to a sustained human presence there. That's the big question, is why? This is despite an ever-increasing technological capability which far surpasses what was available to the Apollo missions. Before we can take another giant leap into space, it might be worth taking some small steps closer to home. Of course, that would be the moon. This is from The Conversation. It's on phys.org. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.